Hi all, in this video we'll be finding the probability that a mutation becomes fixed in the population. So what we will have is, I'm just driving in a couple lines, and let's say dot, 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 dot. So this we'll say is equal to I plus 1. This is I, and this is I minus 1. So I is the number of people with allele A. So if we start here, we can say that the probability that you start at I and then end up at N, so you end up with all the Tostitos, is Q of I, and we can represent this as three different things. So we can represent this as being equal to the probability of coming up, and then later going up to here. So the probability going from I to I plus 1 equal to Qi plus 1. So you went up to I plus 1, and then you ended up winning all the I alleles. So then plus coming down 1, but then coming back all the way up. So this is Qi, this is Qi plus 1, this is Qi minus 1. And then the other option you have is to just stay the same and then come up here. This is Qi again. So this will be the probability of going down from I to I minus 1 times Q of I minus 1 plus the probability of staying put at I times Qi. Now we can use our results from the Moran model because we calculated these probabilities for this situation. So this comes from the Moran model. And just substitute in what we found. So we'll say that Qi is equal to I over N times 1 minus I over N Qi plus 1 plus this is equal to also I over N times 1 minus I over N. And then this is Qi minus 1. And then, oh, sorry, not an equal sign, but a plus sign. I'll erase that. Plus, and this is 1 minus 2 I over N, 1 minus I over N. And then this is Qi. Okay, so simplifying this, we can end up with, so if we subtract this one over to here, what we're going to end up with is just 2I over N times 1 minus I over N times Qi. So there's a Qi on both sides, and we're getting them all onto the same side. And we just end up with, so this will be 1 Qi, so those two will subtract, and we'll just end up with that. And then we can factor out an I over N, 1 minus I over N. So I over N times 1 minus I over N times Qi plus 1 plus Qi minus 1. There's an I over N, 1 minus I over N on both sides. So we can cancel those. And we're just left with Q of I equals 1/2 times Q of I plus 1 plus Q of I minus 1. However, we've already seen this before, and we know that the solution is just going to be equal to Qi equals to I over N. And this is pretty interesting because we started with different probabilities, but we end up with the same result. So now the question is, how can we use this as a molecular clock? So what we see is or what we can say is that if there's some mutation rate per gene, so okay, this is the probability that all the genes end up with the same allele. And if we say that the mutation rate per gene is k, so we'll say that the mutation rate is k, then there are n genes, we would expect that n times k would be the, that this would be the mutations to appear per unit time. However, the probability of a given mutation surviving to become fixed in the population is 1 over n, which we just found. And because there would be one mutation, the rate at which mutations become, so if we multiply these two together, so this is the mutation rate, nk, and the probability that it stays fixed in the population is 1 over n. So we just end up with k, that this is the mutation rate. So this is independent of population size, which we expected as before. All right, thank you very much.